now we're going to give this a listen. We're going to hear about this paper from Apple. But before we get started, I want to share one additional detail that is there's a lot of discussion about how Apple is like a little bit behind the curve when it comes to their AI. And I don't know, like, I mean, in some sense, yes, that I don't know that Apple has demonstrated in a very clear way that they are at the same level of maturity on language models as folks like Amazon, Meta, Microsoft, Google, IBM, all those folks. But also it's Apple. So with Apple, they're super secretive, and they could be cooking some incredible things that the rest of us just don't know about. But I wanted to start by saying that I am well aware that Apple is perceived at least in the Valley, as being slightly behind the times. So Apple coming out with a paper that talks about all the problems that exist in language models has multiple meanings. It's not just as simple, I think, as these researchers wrote this and they're punching holes in all these language models and all of it is factually correct. It could be the case. Again, I don't know. I'm just saying it could be the case that there's more at work here. But in taking a quick sort of scan of the paper, I think that the paper actually has a lot of reasonable things to say, and I want us to do a little bit like of a deep dive, or just go a little bit deeper than skin deep, so we can understand what the paper is, if it's saying something that potentially is meaningful from a scientific perspective, or if it's just a whole bunch of fluff. But before we can do that, we need to have Vanessa talk to us about this.
Unfortunately for these AI CEOs, what we also saw recently was Apple releasing its research paper on large reasoning models. I will have this paper linked below because it is a long research paper. It's 30 pages, but I highly recommend you read it because it's very interesting. The title of the paper is The Illusion of Thinking: Understanding the Strengths and Limitations of Reasoning Models via the Lens of Problem Complexity.
And one thing I want to add is Sammy Bengio is Joshua Bengio's brother, as I understand it. And both of those guys are, so Joshua Bengio, he was one of the three deep learning, they call them the deep learning godfathers or something like that. And so it was Jan LeCun, Jeff Hinton, and Joshua that they all shared the Turing Award for deep learning a couple years back. And so I just wanted to mention this because while maybe Sammy isn't as recognized as his brother, this is someone that is fairly seasoned. And to scroll back here, you can see that he's on this list, which basically, this is a very important thing to understand because Sammy's someone that's so well established that he doesn't need to be on another paper. It's he has enough papers. So more likely than not, this is my speculation, knowing like how hard it is to build a strong reputation of being considered with like high degrees of scientific integrity. If Sammy didn't deeply believe what's in this paper, I suspect he would recuse himself as an author. This is just speculation, so I don't know this as fact, but if I see someone's name like Sammy's on something like this, it usually indicates that this person actually deeply believes in this. This is one of the things that you can get some interesting subtext from the actual text based on understanding the context. Is the same would be true of like Jan LeCun or Jeff Hinton or Andrew Ng or many of these people, Ilya, so on and so forth. Okay.
understanding the strengths and limitations of reasoning models via the lens of problem complexity. I won't go through everything in the research paper because, again, it is very long, but some key points for me is that when the AI is given a clear method to solve the problem, it doesn't use it. The AI can't follow the instructions properly to even solve the problem when given the solution algorithm. It's like
Okay. So let's stop there for a second and let's talk about this. So she's saying that in this paper, she's talking about how one of the weird things about these language models is even when you give them the answer, they still can't fix it, even though you sort of precisely told them where the problem is, what the problem is. This is a bit strange, right? Because if these AI systems understood language, I'm not talking about being a parrot, I mean understand meaning, then in theory, when you explain things like where a problem is and how to fix it, they would understand that form of communication. It would then guide their answers, and you would consider that as like, oh, they are reasoning systems, right? That's what it means to reason. Now, it's been my own experience that, as you can see, right? I guess this one was, so I'm talking to the AI as it's breaking stuff, and I'm basically explaining all of these that you see here, where it's saying I've made some changes, I fixed this, and you don't see me typing anything. So here's this error. Now check this out. I want you to see this. This is, I think, from a couple days ago. An error occurred. API request failed with status 401. Look at the current error. An error occurred. Authentication failed 401. So this one's 401, and then it's gone through, and it's like, oh yeah, I fixed this. This should permanently resolve to this error, right? When you don't see me clicking anything, what I'm doing is I'm just clicking fix error. So this problem, in multiple iterations, it's saying it's fixed it, and it continues to not be able. I mean, like, so you can see. Look at this. This one's super interesting. It's no longer generating images. This is what I tell it. Keep in mind, this is Gemini 2.5 Pro, as I understand it. This is like the most advanced language model that Google has to offer now. I think if I'm looking at the data properly. So here I say it's no longer generating images because it broke itself, just like this right here. And its solution is the core issue is that while we're asking for 16 by 9, we weren't using the correct thing. It defaulted to this, right? Okay, we've been down this road. It just does 1024 by 1024 every time. This has been happening for forever. So then what it does is it's like, I'm going to fix this and we're going to get the aspect ratio, and that's it. It's not the aspect ratio. This hasn't been a problem at all. Or rather, it's been a problem, but it's not something that breaks its ability to generate images. And it should know this, right? Because we've talked about this many times, and then suddenly things broke. It broke in, I think, along the way when I tried to send the meta prompt directly. So when I say it's no longer generating images, and then it's saying, oh, it's the 16 by 9 thing, it does make you wonder. I'm saying it's no longer generating images, and you're saying that you fixed the problem so it'll do a 16 by 9 aspect ratio. That's not the problem. It's not that it was generating an image and the aspect ratio is wrong. It's that there is no image. So anyway, it could possibly be that it thought that this would fix it, but then this is me clicking, no, still more errors, fix this, still more errors, fix this, still more errors. We're just going down this rabbit hole. Then this time maybe I got lazy and I copy and paste this in, and then it's like, oh, this is a very specific issue. We'll get at the heart of this. Each one of these has been this 401 thing. I don't know why it keeps saying it's unexpected end of input. Maybe that's the error it gets back from the call. It's not entirely clear. But notice that each one of these, like I've made these things and now it correctly does this. Again, the confidence of it is maybe the part that's the most frustrating, is it's certain that it's fixed it. It's permanently resolved. You know, it will work this time. Okay, it's really going to work this time. Okay, now it's really going to work. All right, well, maybe this time it's really going to work. Okay, it's going to really work. Oh, this one's separate. That's the API default. Then it's really going to work, and then it's really going to work. And then we can go down this path and click fix error. And my hope is, just like last time, is when we're on stream, somehow some magical thing happens and it does actually fix it. But I don't think that it actually understands what the error is. I think the error is that the image generating service on Google's backend is going down. And it doesn't have the ability to differentiate between an error message on it just returning sort of this empty thing versus an error message that is the service is down. And there's ways to detect this, but it requires you to have deeper, more nuanced understanding of what it is you're building. One of the ways that you can detect this is doing a ping. So, hi there. You can do a ping. If you do a ping on the socket for like potentially, usually for just the server, this will give you insight if the server minimally is up. If the ping doesn't come back, that basically oftentimes means that the server is down or it's lost its like lookup from like a DNS or something. If I were designing this, one of the things that I would do is I would add a line of code prior to the image generator and I would add a ping. And if the ping failed, I would return back to the user, oh, the service is down now because the server's unreachable. Wait until I'll continue to try, or I'll notify you once we get the service back up or the server back up, right? But in order to do that, you would have to be able to reason about the system that you're building and then see that like this is a call that is going into a service that could potentially go down. So I have a call into this API. Sorry, I have a call into doing this ping that's going to help me sort of narrow this down. I'm going to be able to shrink the space a little. So in cases where the service or the server is completely unreachable, I'll notify them that. And you might not be able to get that directly from the API, but you might if you can think outside the box. But if you don't understand actually what you're doing, then you likely are going to do this. You're just going to keep fiddling with the one API because that's the only thing that you think you can change. You're not actually understanding how this works. So you don't understand, oh, there are these error condition checks I can do before this, and I should execute all those, and those will help me determine if I can call the API successfully, and I should do all that before I call the API. This is the way that we were showing code before with the with parsing a file, right? Is that you don't just start parsing the file. You check, does the file exist? Is the file readable? All of these things, right? There's like a list of things, and this is generally considered the proper way to write code. You deal with the error conditions first, and then once you ensure that all of the errors are checked and there are no errors, then you perform the operation. Like this is, again, goes back to how to write code that doesn't never nest, is that if you don't check for all the errors up front, if you just check like, see if the file exists, and then you're like, okay, it exists, go in and start to do it. And then you're like, oh, but now see if I can read it. Oh, I can read it. Okay, go in again. You do the opposite. You're like, oh, the file doesn't exist, exit. Oh, I can't read it, exit. Oh, it's improperly formatted, exit. So then when you get past all those, then you're like, I know it's in a good state. I can call this and it should have no errors. That's, I think, one of the better ways to design this. And clearly this system is sort of, it seems as though it's falling short. Now, what's interesting is that my hope is that clicking this button will actually work now. But if it doesn't, I think that this is more information that is telling us it's probably related to the service. going up and down, and maybe not related to an incorrect API call. The other thing, yeah, so it's still broken, right? And again, it's certain that this is going to work perfectly, right? And it's clearly not working perfectly. Okay. The last thing I want to share is it was saying that this problem was like introduced as we were adding this send to metaprompt directly, but the truth is it was actually happening before this. And we didn't change anything in the code, me and my AI friend. We didn't change anything in terms of the way the API is being called when we did this. The API is still being called exactly the same way. It just forwards the prompt from this directly to this, like here. Or actually, yeah, we'll close this and you can see me click this. What happens is it forces this to get sent down. The reason why I did this is so I could do this. So I was asking it for create these logos, excuse me, create these logos for GTT, and it kept expanding it into like this really sort of incredible hyper prompt, and it kept wanting to have a person in there. So it kept producing these images that were people, they weren't logos. So I was like, okay, I want the enhanced prompt, but there are some cases where I need the enhanced prompt to not get created. So instead, I want to be able to send the meta prompt directly, which is why I added this. So in theory, if this works correctly, what you should see is it will take this, it'll drop this into this, and then that's what it will use. And you can see it did it. Right? It took this, it dropped this in, and now it's using this. Now, hopefully this will work. Maybe. Okay, it worked, right? That's great. Okay, so now we're going to see something else here. I'm going to try to generate again. Now it failed, right? Now it failed. This tells me as a human, something else is going on, and it's not the API, because we just saw the API work. But now we saw it didn't work. So this is 2 out of 3 tries that it's failing. This gives me a clue that the actual code is correct because it can get a proper response. It gives me this intuition that what's actually not right here is the error cases for the reliability of the actual service is not being properly checked. That's my speculation. But in order to figure that out, you would actually have to have an AI that is able to do some sort of intelligent reasoning. And it goes back to what Vanessa's saying. I want us to listen to this again. She's talking about how even when the AIs are prompted with like the right thing, and they're basically told how to solve this, they ignore you, right? It kind of goes back to my point about how you broke it's no longer generating the images, right? Wherever that was, wherever I say, yeah, it's no longer generating images. And it's like, oh, the aspect ratio is wrong. Let me fix it. I didn't say anything about aspect ratio. I said the images are not being generated. Okay, so let's watch this segment again, and then let's keep trudging along.
Like giving someone a recipe and that person doing the recipe in different orders and not even checking if they're doing it properly. Another surprising thing was when the lens
Go back
of
just a little.
problem complexity. I won't go through everything in the research paper because again, it is very long, but some key points for me is that when the AI is given a clear method to solve the problem, it doesn't use it. The AI can't follow the instructions properly to even solve the problem when given the solution algorithm. It's like giving someone a recipe and that person doing the recipe in different orders and not even checking if they're doing it properly. Another surprising thing was when the AI is presented with a more complex problem, it actually puts in less effort rather than more. To quote the paper, it says accuracy progressively declines as problem complexity increases until reaching complete collapse. We have
Okay. And this is the part that I think is maybe the most important. So let's just see if we can scroll back just a second here. I really like
declines as problem complexity increases until
okay, problem complexity increases until reaching complete collapse. So in the past we've spoken about model collapse, right? The model collapse It can happen in a variety of ways, but one of the ways you can get model collapse, as we spoke in the past, is you can continue to retrain on the AI's own output, and then it becomes an echo chamber, and it just gets smaller and smaller and smaller and smaller until essentially it's so overfit it just produces sort of nonsense, right? That's one way to essentially have model collapse. This is potentially another, is that when the problem complexity gets so large, then the AI gets so overwhelmed that there's an inverse relationship between the problem size and the ability for the AI to actually solve it. And at first, this may seem like this doesn't make sense. Why wouldn't it just work on it harder, right? What happens, I think, though, is that it doesn't understand what it's actually doing in many of these cases. And so, if it did understand, a larger or more complex problem would just take it more time. So, for example, if you're adding three numbers together, the number 5 three times, you're going to get the number 15. And let's say that that's within scope. Now, if you increase that problem to where there's 100 of these fives, it's the same problem. It's just more operations. So if you understand the operations, you actually semantically understand what you're doing. Adding more of these should have no effect. It's just it's a mechanical process of reproducing it. And so there's like no calculator that I'm aware of that if you were to you change the number of operations, that suddenly it would like have full system collapse. Like, sure, if the calculator was programmed in an extremely poor way, you might run into this. But if you have someone that sort of understands how to do partial evaluation, then what it could do is it sees the addition operation, no matter the size, always as essentially three elements. There's the first number, the second number, those are the numbers to be added, and then what's left. And it's always that. So the first number added to the second number, that's going to give you a result. And then what's left is everything else. Then the second operation is you take what's left and you break it into the first number and then everything that's left. Then when you go to do the second addition, it's the result from the first operation. It's the new second number and everything that's left. It's just iterative breakdown of the problem. So there's only ever three numbers, right? That way, you never exhaust memory. You just iteratively go through this. Now, it may take a little bit more time, but it's just a mechanical process. So along the same lines, if you have a system that understands the semantics of the operations that are performing, if it has increased problem complexity, but the problem complexity is of the same nature of the prior problems, it shouldn't actually change the results that you would get for the system. It would just take longer to get the results. It's only if new novel elements in the problem complexity were introduced that it's like a number of novel things that you might get into the case where it's like there's too much novelty and I can't deal with all of this. That's not that's a much harder problem. Now, I wanted to pause on this because what you're seeing over here is a very similar thing, right? If we turn this back off, right, we're going to try to generate this, and we're probably going to get this, it's going to generate this meta prompt, and then you're going to get into, it's going to generate the enhanced prompt, and then we're going to get into the same problem, right? Why can it not fix this when it could fix the other stuff before? In short, the complexity of the problem, I think, is starting to exceed its ability to reason about this inside of its context window. And so now we might literally be like, and think about this. This is crazy. We may be at the point of full model collapse with where we are. And if that's the case, we're cooked. There's sort of nothing else we can do. We can't fix this. The way to fix it is we have to go in and fix it ourselves because the problem has now exceeded the space in which it can reason about it. And so it goes from whatever success it was having on fixing these things to zero. And as you can see, like you saw from the the number of cases I showed in the history, you've seen 2 cases, I think, or maybe it's 1 case of me trying to do this live and it's still failing. And so it's still happening. And what makes matters potentially even worse is it was at one point showing that there's like this fix error button, but now the fix error button is even gone. Maybe that's related to this. Let's try to delete that and let's try, because the fix error is at least it's giving us a button of what the actual issue is. So then, yeah, so like now we might be even in a worse state than we were before, because at least before we were getting the pop-up that said fix error and then the system would trigger. Where has that gone? That actually like I don't actually know where it's gone. So I wanted to share this because I know a little bit about how these systems do reasoning, and I don't know all the details about how each one of these systems is doing reasoning, but I understand the core properties of how you traditionally do things like logical reasoning for program synthesis. And keep in mind, what we're doing over here is program synthesis, right? This is program synthesis because it's a program that we're synthesizing. And traditionally, the way that we've done program synthesis is it's walking through a bunch of things that it understands, and it's sort of like walking this tree. In order to do this at scale, you historically have run into like an upper bound on what is possible computationally, because the tree gets so huge that in order to sort of walk all the different branches, you have to have enormous compute. Now, I'm not an expert in program synthesis, at least in the formal path. My expertise is a little bit more on the machine learning side and how to do it from a machine learning perspective. But a lot of my friends are experts in formal methods for program synthesis. And based on what they've shared with me, that this is essentially computationally intractable to do large-scale program synthesis using formal methods, given the power of today's compute. And so if that's the case, that means that these reasoning are not doing sort of true reasoning as we've done using things like formal logical solvers, things that you'd get in like SAT solvers and SMT solvers. They're doing something else. And again, the reason for that is if they were trying to use those traditional techniques, this would be computationally intractable. It would basically say, okay, I'll get you the answer, but it's going to be in 2 years, right? So it's not taking 2 years. And maybe there's been advances, but what I think is that it's trying to tease out like a small amount of reasoning, but they're overloading this word. That it's like the word reasoning means that you're using logic, right? It's sort of like an understanding that you're reasoning about this in a very logical way, and logic has fixed parameters on the way that it works, right? So let's go and say, what is the definition of reasoning? Right. It's the act of thinking about something in a logical way. The logical part is super important. Logic has principles that must be followed, and if you don't follow the logical principles, it's not logic anymore. It's something else, right? So like if you have an emotional reaction to something, that's not logic, that's emotion. Right. Logic is I'm going to go to the grocery store and I want to buy these groceries. And so then you go to the grocery store and you buy the groceries. You're following like a preset number of rules that are going to get you to a logical outcome. And you're doing this because you're trying to understand, in this particular case, can you build a program that will have certain behaviors, and you can do it in a logical way where the system can actually reason, right? Like what this word actually means, which is applying logic to a problem. Can it actually reason about this to understand the semantics of what it's doing? And so my understanding, at least based on where we are today. And again, not an expert, but I have friends that are. I think that we're overloading this term, this reasoning part. Well, I mean, like at Merle, we do reasoning, but we actually do reasoning. There's a way to do, I can't get into the details of this, but there's a way to build some of these systems to where it can lift out semantics. And once you start lifting out semantics, you can start to reason about things in a real way because you're not just looking at syntax anymore. Like, for example, you could have the word green, red, orange, blue. And if you look at that just from a syntax perspective, those are just letters that create a word. But from a semantic perspective, you could look at that and say all of those words are colors. And colors have a very specific meaning. And so now we can say, from a semantic perspective, it's each one of those words is in the space. Its meaning is it has a color. Once you can do that, then you can start to understand, okay, so what are colors used for? Well, they're like things have colors. And you can probably see how once you start to do this, you can begin to reason about things in terms of what they mean. This actually goes back to a point that I think Jan LeCun was making, which is that language models don't understand the world. What I think he's trying to get at there is that the language models are just essentially stochastic parrots. They're just memorizing stuff and they're saying stuff like a parrot would, but they don't actually understand what they're saying. And it turns out with like enough compute and enough vocabulary, they often say stuff that has the appearance of being meaningful, but because they're not true reasoning systems, you can have massive logical fallacies that they fully believe are true, but it's just not. And I think a very simple example of that is the number of times the system is like, I fixed this, it works now, but then it doesn't work. That is a logical fallacy because you just said you fixed it and it like guarantees that this thing is correct and then it's not correct. So both of those things can't be true. It can't be fully correct and incorrect at the same time. One of those things is false, and we know which one is false. It's the fact that it works correctly. That gives us some insight into that this thing doesn't actually understand what it's doing or what it's saying. And that's a real problem when you get past the space of what it can store in memory to be a stochastic parrot. Like another way to think about this is imagine that you have something that can memorize exactly what the right answer is, but only up to 100 words, right? And so any problem in any domain, as long as the answer can be captured in 100 words, it will do perfectly. Cool. What happens when you get beyond 100 words? In this case, you can have like full system breakdown. So then this raises this other interesting question of like, what problems are we going to solve where we can concisely capture what the answer will be in exactly 100 words or less? And I don't know that we necessarily can do that. And I also don't think that this is going to be useful for the cases where the programs start to become large in size, which is the byproduct essentially of any piece of software that is going to be used, is that it's just has a natural tendency to grow because software that actually has value tends to increase its entropy because more features are being added. You forgot error conditions, you're patching things. This is all just more code, right? And this is a good example, I think, is that this app that we started, this vibe system that we started building, it was maybe 100, 200 lines of code at first. And now we've reached this point to where it's like around, over 1,100 lines. And maybe this is the limit. I don't know. I'm not entirely sure, but I think that Vanessa is absolutely on point calling this out about how we get to model collapse. This is probably, in my mind, one of the most important open questions that exists in the AI space with respect to language models because they don't actually reason. And to be clear, I don't know how to solve this. I mean, at Merly, we're doing stuff with reasoning, but we're actually doing real reasoning, and we have it set up to where it's computationally bound. It's done in a way that we can get to the answer. It has to do with the way we break things down. It does have limitations, though. That's generally the side effect of doing things that are like highly complex and they're done sort of in a scientifically rigorous way, is that the mentor system can't reason about things in a in like a holistic way with context over an infinite number of lines of code. It cannot do that. It can break things down into individual pieces and then reason about the individual piece and then slowly build these up, right? But this goes back to the tree problem, is that so we can do one pass and reason about stuff. Then we want to do compression to bring these ideas together. Then it can do a second pass and it's tighter and tighter and tighter. However, each time you do this, you're doing another passive inference. So this is going back to what Vanessa's talking about, is it just takes longer. That's like a real reasoning system, is that it doesn't just fail and Mentor doesn't just raise its hands up and say like, I can't do this. It just takes longer. And so a concrete example of that is if we go to summaries, right? Hopefully you'll get to see this live, is if we pick some random repo, yeah, we can actually use Visual Studio Code. So we'll just pick some random anomaly, but we'll start with something that is not super complex, okay? And let's do an experiment here. I'm going to turn on my stopwatch, and so I'm going to click on this and click the stopwatch. And my hope is it hasn't seen this. It will know right away if it's seen this before because it will have buffered the answer and it'll know what the insights are. If it hasn't seen it before, I'll have to think about it. And you'll be able to tell that the right side of the screen won't be fully populated. Okay, here we go. Okay, so in this particular case, okay, it did know. It just took a while to pull it all into memory, but it did know, and you can tell also by this 3. So we can actually, we don't even need to add the timer. We can just use this. So let's try maybe this one. Okay, cool. This one, it doesn't know about, and you can tell because it's thinking. And you don't have the number. The number here is going to be 1 if it's doing what I think it's doing once it figures this out. Okay. And maybe I did actually start the timer. So I did it like a second late. So here you can see the 1, which goes back to what we were saying. It's never seen it before. That's why it has to do this additional analysis. Okay, that took about 20 seconds. All right. So now let's go to pick something that is much, much longer, like this. Okay, here we go. And we should, okay, this one's been seen. So that's not helpful. We need to pick one that it has not seen. And I want something that's super long. Okay, let's try this one. We might have one here. I think we do. I think we've got one that it's never seen before. Okay, so what it's doing is it's processing this expression, and it's also building things up on this side. Okay, cool. So that took us about 20 seconds to get into this. Notice that this expression is notably more complex than the other expression, right? Now, it's still thinking. It's still trying to figure this out. And that's because it's doing what we were just talking about. Okay, it's done now. So this is like an example of the first run where it was smaller. It only took us 20 seconds. This one, it took us twice as long. It took 40 seconds. So this hopefully gives you some insight on what I was describing, is that when you have a real reasoning system, you are going to have incrementally more time to solve the problem, because generally speaking, I mean, there's many ways to order the logical reasoning of things, but the simplest way is to do it serially, right? You just start at the beginning and then you iterate over and over, and then you eventually get to like the 305th number of the Fibonacci sequence, right? It's not to say that you can't figure out the Fibonacci sequence in parallel. Maybe you can. I mean, I don't know that I've seen a parallel implementation. Maybe somebody in the chat or in the comments can share that. But you can imagine doing Fibonacci numerical sequences. It's very easy to do if you just do it serially. When you do it serially, what happens is the amount of time that it takes to solve the algorithm for farther and farther out numbers in the sequence will just take more time. It won't get model collapse. It won't just like start doing it and then, oh, I've reached number 19, fail. It'll just take longer. And so this is one of the clues that you have when you're dealing with a system that is doing deep reasoning. And the truth is, I think some of these might be, because I've seen this when they're doing like a deep reasoning, it does take them like twice as long. That's actually, I mean, as strange as it is to say this, that's actually a little bit of a good sign, because it says that there's a chance that it is doing some reasoning. Maybe not to the degree that we would like it. It's probably skipping a lot of steps, but hopefully in a way that makes it better rather than having like full model collapse. I don't know. Anyway, that's basically all I want to talk about in this case. Oh, and you know, I strongly encourage all of you to check out some of Vanessa's stuff. I'm sub now. I've watched 2 of her videos. Her one on OpenAI is just totally on point. And I also found this one to be really on point. She's doing, I think, a fantastic job calling a lot of the hype in AI out. And I think it's kind of what I've been trying to do as well. It's tough, right? Because we're obviously in the space of AI. This is something I've been working on for quite some time. And I realized that like us coming out on some of these AI companies that are doing stuff a little bit sketchy, it'd be very, it's important to make sure that there is a view that we could be part of that as well. My hope is that by watching this, you can see that at least our attempt at Merly is to try to do this in the most, with the highest degree of integrity. And it's not to say that we're perfect, right? We make misses, but hopefully not the level of misses that that we saw. Like, I can tell you definitively that we have misses, but there are no misses that we've made at Merly that come anywhere close to this type of thing. Like, our mistakes are mostly Goju is just dumb, right? That's the level of it. It's not like there's intentional malice like there is, or intentional deception or fraud like there is here. So anyway, strongly recommend you check her stuff out. I've watched 2 of her videos now, and I think it's super awesome what she's doing. And I look forward to like tons more interesting takes that she has. I don't know what her background is, but I love that she has a really good critical analysis of these AI systems, and is like she's, as far as I can tell, she is on point with the things that she's calling out, that she's using. She's not just speculating, she's using a lot of evidence to guide the types of conclusions that she's coming to. Like, for example, in the video where she's talking about Altman, she just uses all the data that's out there and basically catches him on a complete logical fallacy, right? Because he's saying one thing and then he says something else, and like, these 2 things cannot coexist. He basically, I think at one point he says, I have no equity in OpenAI, yet then later on we find out that he does have equity in OpenAI, both through like this open AI startup fund, I think. No, sorry. It's through the Y Combinator Fund and then the Sequoia Fund. And so the Sequoia Fund, he was an investor, and then they invested that money in OpenAI, and then Sam cashed out, right? But clearly did have equity in OpenAI at that point. And then the second one is like the Y Combinator equity, where he's saying it's much harder, much more difficult for him to liquidate on that. I don't know the details of that. Uh, maybe not. But it's clear that those two things sort of don't exist. Either you have equity or you don't. And the sound of it is he did minimally have equity in two different forms, through the Sequoia Fund and through YC. And it sounds like he still has it through YC. So if he still has equity through YC, how is he saying that he doesn't have any equity? Like, these how can you have something and not have something? So I mean, like, I get it. If we live in the quantum world where we have like two states that exist simultaneously, sure. But in the objective reality that most of us live in, it's like either I have a dog named Merle or I don't have a dog named Merle. I can't simultaneously have the dog and not have the dog. Maybe I'm just too stupid to understand that someone can explain this to me, but whatever the take, I'm glad that we got to do a little bit of a deep dive on this. Uh, I think for the next podcast, I may follow up a little bit on what Untranslatable Metaphor was asking for, which is a deeper dive on some of the specification stuff I was doing in C++. But I also want to do some meandering on life virtues. So we may get some of those this weekend. And I may just randomly jump on and just start doing another stream. I also, too, just as for kicks and giggles, I want to just kind of meander and talk about video games a little bit. And what I might do to demonstrate the issue that I have with Cyberpunk is I might do my first live stream of me playing Cyberpunk, so you can see how I can't get into third person mode, and you can watch me visibly get nauseous as I'm trying to play this, and it's like I can't do it. Or maybe what I'll do is I'll take some Dramamine, and the Dramamine will essentially help me power through it. I'm not sure, but thank you, Jeters. It's been super fun. I hope you guys have a great rest of your weekend. And yeah, we will. Yes, absolutely, T. It's basically Schrodinger's cat and Goju's dog is touche. That is like so absolutely on point. I love that. Like that may be one of the best puns you've come up with that I've heard. Like, oh yeah, super great. Okay, thanks everybody. We will talk again soon.